Hello, everyone. My name's Corey, and well, welcome to the first episode of what I hope is going to be an interesting time of developing my own programming language. And well, I tell you what, we'll just jump into a few points. And that is the first question that people are going to say is, why on earth would you create a new programming language? Aren't there enough of them out there already? And the answer is, of course there are. And of course, there's not enough programming languages. We need another one. There's a lot of reasons why someone might create a programming language. Maybe it's just fun. And if you don't see the fun in creating your own programming language, I don't know whether or not we can be friends. But if we can get past that, uh, it's just going to be an interesting thing to do. It's educational in terms of I've never gotten to create one before. And I didn't want to create, I know a lot of people, when they go to school and everything, they'll take a compiler's class and you might create a Lisp-like language. And nothing against Lisp, it's a great language. But it's one of the easier ones to be able to create, and I have specific ideas behind what I want to do with this language. So yeah, it's just like this will be a great thing. Profit, probably not going to make any money on this. In fact, I don't even see a way of making money. I'm doing this because I want to. And anyway, all right. But that's my motivations. What about the practical, how it would affect someone else? What can my language offer? Well, I am trying to write a language for a very specific use case. And that is, quite frankly, I want to have an application that's written in C++, but I want an end user to be able to have some sort of customization. And you can do that by giving them a scripting language of some sort. And of course, I know there's Lua and there's a few others, but there's reasons I'm not choosing those. And so, just as a general statement, why might you want to develop your own language? Well, because to give your users something to interact with, something that you've written. And let's face it, compiling can be complex just to get all of the parts together. We'll see that as we start to put all of these parts just for this project together. And by providing them your own programming language, you make that easier for them, perhaps. I say custom problems require custom solutions. Sometimes the languages that exist aren't the best fit for the problem you need to solve. Or it can work. I mean, quite frankly, modern programming languages are all very, very powerful, but sometimes they are too complex for their own good when it comes to a beginning end user. Or it would take someone too long to get acquainted with it. So you want to give them something simple. But maybe some of the simplistic languages are too simple, and whatever. Okay, we're going to design a language that does what we want it to do. There are domain-specific languages, and so you can take these ideas and create your own, maybe even smaller, simpler parsers and tools that again can be quite powerful. But anyway, just a lot of possibilities there. Here's an interesting one. I want to be able to protect the end users from themselves. What do I mean by that? Well, if you didn't know it, in programming, a lot of people copy and paste code, and that can be dangerous. They can copy and paste something malicious, or just something that they don't know it's doing. So you want to be able to keep them from being able to intentionally misuse your resources. So, for example, if you give them an all-powerful programming language, what's to keep them from accessing files on the hard drive or making network calls out, to something else, leaking information from the user's computer? I'm thinking if you were to, for example, create a script for a game plugin, and you provided a scripting language, you would not want the users to be able to, like I said, access the hard drive or do things masquerading as the user who's running the program. And if if you're watching this, you should know what that means, right? With the user level permissions and anyway. So there are things that you want to protect them from intentional misuse. You don't want to have again maybe a game plugin that someone is writing and they're mining Bitcoin in the background. Maybe not that mining Bitcoin is bad, but you don't want them to be able to take advantage of someone's system. But also accidental errors. What if they write a loop that is an infinite loop, for one? You want to be able to catch that. Or what if they don't know the difference between a string and an int and a float and they try to divide by 0 and things like that? You need to be able to protect the end user from those sort of silly not silly mistakes, but those things that could happen. And so those are all different reasons that you might want to create a scripting language, something that is a sandbox, that you can control what goes in and what comes out of it for a specific use case. I'm not trying to create a general purpose programming language. I'm trying to create one that fills a need. All right. Having said that, let's go on. So what's my goal? Well, the hardest thing of any project is to come up with a name. And in this case, I came up with Tang. Well, hence the color scheme, because Tang is a kind of drink that many people are familiar with. But that's not the other thing. There's also fish by their Tang fish. Yes, there's a blue Tang and a lot of different colors and type and species, I suppose, of Tang. There are cities with that name. There are people with that name, with that surname, I believe. And yeah, so okay, I liked it for the meaning of template language. It's my template language, so I chose Tang. And I'm giving you a peek at what it's supposed to be doing. I want it to be able to generate HTML text. And there's a lot of things that go into that, and I don't even remember if I listed them on this slide or not, but we'll talk about the basics of the language first, or what goes into making the language. So first of all, C++. I like C++. I like C. I like a lot of languages. I like JavaScript. I like Java. I mean, there's a lot that I like. But C++, modern C++ is a completely different animal than it used to be, than it was 2 decades ago. And I've never gotten to study it. So, you want to learn a language? Do a new project in it. Why not? So I chose C++. I want to use Flex and Bison. These are 2 tools, and we'll talk about them more later. Been around a long time, but quite frankly, I had trouble finding documentation over how to use them, especially in the ways that I wanted to use them with C++. And well, we'll talk about that. That's part of why I wanted to record these, is because there were huge hurdles in getting all this working together. I want to have reentrant code. A lot of the examples are not reentrant. That is, if you've got one instance in one thread and another instance in another thread, it's not thread safe. That's what I want to say. So I wanted to make mine reentrant and use the modern versions of Flex and Bison. A lot of the documentation, a lot of the examples out there are using older versions. And okay, we'll get through that. Doxygen. Oh, a great tool. Commenting your code using Javadoc syntax, and then Doxygen can generate all of your reference material. All of your complete documentation site using Doxygen. We're going to do that in this. Unit testing. Oh my goodness, unit testing is so great. For some reason, students hate to write tests, and it's probably because they don't see a use for it. But trust me, when you need to refactor something that is of any size whatsoever, any code base of any significant size, you want to have unit tests, because or even when you're just adding a new feature, you create a new feature and the unit test will tell you, oh yeah, you broke this thing back there. That we're going to be dealing with unit tests using the Google test framework. let's see what else. Good documentation. We'll be uh, doing examples of that. But I mean, the point is, I want this to be something that someone else can use as well. And quite frankly, I'm going to forget how it works if I don't document it properly. So, yep, we're going to do that. It's inspired by PHP and Python, and I should say even C++, and a few other things I've used over the years. So I think it will be logical, but I'm trying to take good parts out of these languages and enhance them for the purpose that I'm trying to build this. That is the generating the HTML. All right, and I want this to be extendable via an API. What do I mean by that? Well, if Tang is the base product, I want someone to be able to write something else in C++ that's kind of like a plugin for it and can enhance the capabilities. Maybe someone writes a library that can do whatever. I don't know yet. I do have ideas, but it's for an extended use case. But all I care about right now, I want Tang to be extendable via some sort of API. We'll be looking into that. Oh, UTF-8 support. I say multilingual, but maybe when I wrote this, I had one thing in mind, and then I thought it couldn't be done, and now I'm thinking it might be able to. But what I really care about, I said UTF-8, I should have put Unicode support, because quite frankly, even a lot of the big languages don't support Unicode by default. And when I'm talking about generating HTML text, that means using, again, I want to use the UTF-8 encoding of Unicode characters, and I'll talk more about the difference, what does UTF-8 mean, what does Unicode mean. But then HTML has an encoding for it, or if you're having to do percent encoding, like you're putting out a URL, I want a language that just handles it automatically so that the end user doesn't have to know how any of it works. They just say, print out some value, and it prints it out in the correct format. I'm going to be building that. It's sophisticated and non-trivial. I don't want to just build a toy. I want to build something that I can use and something that someone else can use. And let's see. I want to understand all the parts. Yes. And I want you to understand the parts. And so that's why I'm building this. I mean, between you and me, I've already built this thing twice, different ways each time. And this third way that I'm looking at building is like, I think I figured out all of my, the shortcomings of the first two ways. And yes, I've read books on compilers and language design and stuff like that. So I'm not saying the mistakes there, but just ways I was playing around with C++ and different ways of representing the language, of executing the language. And so this run through is not going to be me copying and pasting stuff in. I'm writing it from scratch along here with you. And of course, we'll be using Git. So there'll be a Git repo that you can go and say, well, okay, I just watched episode 6. And in the Git repo, there will be a tag for episode 6, and you can see the state of the code when I finish that episode. And I say Vim and YouTube. Well, if you're watching this on YouTube, you get the idea that I'm planning on putting this on YouTube. But Vim, why Vim? Because I want to do it. I want to learn to use Vim better. Quite frankly, I deal a lot with servers. Recreationally is the word I'll use. I don't professionally. I am still in technology and everything like that, but I'm not doing server work. I used to be a full stack developer, and I still love the command line, and I would rather SSH into a server than have a GUI at all. But I want to get better at Vim. So how do you learn a tool? You build something. And so I'm going to be building a lot. And if you are a Vim expert, be ready to cringe at some of the really roundabout things that I do to get stuff done. And then you can leave a comment and say, yeah, it'd be better if you just did this or use this shortcut, and it won't hurt my feelings. In fact, that's the point of this, is to get Vim under my fingers better. So that's my goals. So, okay, what are the expectations from both of us? There's going to be live coding. I will hurry through some parts because, quite frankly, some parts of this will be very repetitive. For example, when you're implementing the plus sign, and then the minus sign, and the divide, and then the multiplication, and then the modulo, and then the less than and greater than, less than equals, greater than equals. Yeah, that might be a little... what's the word I'm trying to say? Plotting. It might be a little tedious. So there will be live coding. But hey, that's the kind of the point of this. There will be mistakes, I guarantee. I promise. I will try to make sure that at the end of each episode that we are in a compilable and runnable state. But there will probably be mistakes, and I will make them, and well, you'll see as we get there. Intermediate level C++. You don't have to be a C++ expert because I am not a C++ expert. I've taught the language before, but mostly to beginners, and we couldn't get into the advanced concepts anyway. And I've always wanted to play around with them, and I've already found some things that I like and some things that I don't like. I am targeting C++ 20 because, well, why not? It's at the time of this recording, it's 2022. And so, yeah, I'm targeting that. How many features will we use from it? I'm not sure. In my last build of this language, my last run through of it that I did personally, I use several, but my goal is to explore the language, as long as we're not sacrificing efficiency. Patience, yeah, this is not my day job. I'm not a YouTuber I'm not even a YouTuber. I'm just a guy that's recording stuff. Yeah, I don't make money at this, but I'm doing this because I hope you enjoy it. And hopefully, you know what? I hope that you feel like you can be a part of this and add your comments. If you want to add a feature, merge request, more than welcome, right? Well, we can look at that. So, all right. So I'm hoping that this will be a benefit to you. All right. So first of all, let's look at the overall structure of building a language. What is it going to take? There's several things that we have to do to get from the code, the script that someone writes, to the results of executing that script. So I'll say there's the script that is provided by some sort of end user. So it's going to be maybe a designer. Since I'm thinking about something that's for HTML templating, this might be, like I said, a designer who's providing a template, right? This is like I said, template language, Tang. So it's provided to us by someone. Now, what we have to do is we have to use a lexer. What on earth is a lexer? Well, it parses the text into lexemes. Well, what does that mean? All that it means is it breaks apart the text into parts that it can understand. And the one that we use is called Flex. And I think that the original program, or what this was the Flex program was inspired by, was called Lex, as in lexer. And of course, these are like language-specific terms, and by language I mean like, English language grammar. That lexemes. If something is in alphabetical order, it's in lexicographical order, or lexicographic order. Anyway, yeah. So the original program was called Lex, and evidently I think this is fast lexer, so it's Flex. It will take the script and will break it apart into the different things. It will, and I'll give you an example of that in a moment. Then we have to parse it. So once we've got the different parts, we have to say, and how do these relate to one another? Well, that's what we have Bison for. And Bison, originally, or the original program you would use for this was YACC, Y-A-C-C, yet another compiler is what that stood for. And of course, because computer scientists like to do puns on names, yet another compiler, or YACC, they said, well, this is an advanced YACC, so this is a Bison. Okay, it's a stretch there, but what does Bison do? It will take all of those parts that Flex gave us and say, oh, this is an if statement. Oh, this is a while loop. This is a variable assignment. A is equal to 3. Something like that. Okay, so that's what Bison does. Then we use that structure that Bison figures out, and we create an abstract syntax tree. What is that? Glad you asked. An abstract syntax tree is a way of representing the structure of the code, as opposed to having one long text file that's just a string of characters. Now it is, well, you can think of it like a tree structure, but it's, you can say there's an if statement and it has an expression, and it has a body, and it maybe has an else part that if the expression is false, execute the else part. Okay, don't worry. I'll give you more concrete examples of this, but this is just high level overview. So the abstract syntax tree. And lastly, there's the compiler. You'd say, I thought this whole, all of this sounds like the compiler. And the truth is yeah, if you've been dealing with a lot of programming languages, and that is you write your own code in C++, and then you compile it using G++ or what are the others? It doesn't matter. It's doing all of this in the background. It's having to lecture program and to parse it, and it creates an abstract syntax tree. And there's some other stuff in its intermediate representation and how it will optimize the code and things like that. But the compiler is doing all of that, and then we're not even getting into, our system doesn't do linking and things like that like the G++ compiler would. But what our compiler is going to do is it's going to take that abstract syntax tree and convert it into bytecode. This is our own bytecode. You may have heard of the Java bytecode that's executed by the Java virtual machine. And well, this is the Tang bytecode that's executed by the last thing, our virtual machine. Yeah, that's what we're doing. Script, a lexer, starting with some script, we're going to lex it with Flex. We're going to parse it with Bison. We're going to create an AST, an abstract syntax tree. We're going to compile it to bytecode using our own compiler, and then we're going to execute it using our own virtual machine. Oh yeah, this will be good. All right, let's see. I'm on the wrong side. There we go. Okay, that's slightly better now. Just to give you a little bit more info about how the lexer and the parser works. First of all, a lexer, well, stop and think about this. A computer doesn't ever see the big picture. That is it. Quite literally, computers are stupid. They're just really fast. And they can usually only compare two things at a time. It's just they do it really fast. And so as programmers, we create structures that, make it look like they're doing a lot more and make it look like they're a lot smarter than they are. But if you think about it, every command you write is generally only comparing two things at a time. Or it's an abstraction that boils down to that. Well, a script that someone has written is a big blob of text. And the computer, when it looks at it, it sees a character followed by another character, followed by another character, followed by another character, and so on and so forth. It doesn't know what if means in terms of if. That's what the lexer is for. The lexer goes along, and if it sees an if and then a white space, it says, oh, I recognize that. That's an if. But if it sees I, F, O, I, foo, whatever, I don't know. Because it didn't see white space right after the IF, it doesn't say, ooh, I saw an if. That would be a naive way. No. It tries to see how long of a string it can match, and so since it sees the IFOO, it'll probably say, again, we're going to be writing its behavior, but it'll say, oh no, this is an identifier, like a variable name. Or maybe if it sees print, it'll say, oh, this is a print statement. Yeah, we'll be doing that. I mentioned here like a 3, or maybe the number 42, or a negative number. The whole the lexer figures out what the clumpings together are, and it's called tokenizing, or it creates tokens for each one of these, and then it passes it to the parser, which is Bison. So Lex creates the tokens, or lexemes is the other word for it, and passes it off to Bison. So what does Bison do? Bison is our parser. Well, first of all, of course, it's going to receive this stuff from Lex, and it looks for the patterns in it. It looks for variable plus integer, a plus 3. And it says, oh, that's an expression. And maybe it's a plus 3 plus b. Well, we would have to, the compiler would have to say, well, I need to do a plus 3 first, and then I can say whatever the result of that is plus b. That's what Bison does. It gives us the structure. All right, and that we capture that in the abstract syntax tree. Okay, so let's look and see what this might look like. Suppose we have a script here. Very, very simple. But this would work in Tang very closely. Anyway, and we've got a script. If y is less than 10, print y is small. Not exactly as elegant as Hello World, but you get it. Okay, so what do we do then? First of all, flex would identify tokens, and it does it in order because it's consuming the letters. So what do we need to do? It would see an I, F, and then white space. Well, the if, it would say, oh, there's a token I recognize called if. Okay. It would then see the left parentheses. Oh, okay. There's a token that I recognize that's a left parentheses. It would recognize the y and it would say, oh, I'm going to say that's an identifier. Less than, I'm going to say that that's an operation of some sort, a comparison or whatever, a binary operator. I'll talk about that. And you can go through and match up everything from the double quoted string, which is right here, y is small, and that could be a token. The semicolon could be a token. The braces, those are all tokens. Okay, so Flex doesn't know anything about, it could be gibberish, but it just is trying to recognize what it can of that. For example, if you wrote a script that said, if, semicolon. That doesn't make any sense. But that's not Flex's job. Flex's job is to just recognize that you've got an IF, white space, IF, and pass it on to Bison. Okay, so what happens with Bison? Bison looks for patterns. And these patterns are called a grammar. And I'm not going to go over what it fully means. But all that, to understand a grammar, you can think of it as things that can replace one another. So, for example, I think I've got something highlighted here. So, an if statement. Here, let's say this if statement. It would be the tokens of an if followed by a left parentheses followed by an expression. Well, expression was not given to us by Flex, but expression is something that Bison could say, oh, but an expression could be an identifier followed by an operator, then an integer, in which case that's what we see here: identifier, operator, and integer. And it could then substitute that pattern in, and that kind of lets us see an overall structure. And I know that this is high level. Trust me, I've taught grammars, and it's usually a couple lectures dealing with terminals and non-terminals and production rules and what yields what and all the proofs behind it. Don't worry, we're not doing that in here. The examples will be clean enough as we get into it. But, and I'll show another one here that there's a code block, right? And a code block may be a left brace followed by a statement followed by a right brace. And I don't have an example here of what a statement could be because this is supposed to be something simple. But all that to say, this is what Bison does, is it breaks it down into that. And now, what does the abstract syntax tree look like? Well, it might look something like this. Again, the point of it is to take this code that Flex tokened out for us and gives it to Bison, and Bison recognizes the pattern so that it can produce something that looks like this. Maybe a node in the tree that says, oh, this is an if expression. It has a condition and it has something to execute if the condition is true. Well, what's in the condition? It's an expression. You'll recognize that from the grammar. And what's the expression? Oh, it said y is less than 10. And again, I think you can see the overall structure here. The hard part about this is you got to hold it in your head. Well, I mean, you can draw pictures and everything, and quite frankly, yeah, I did draw pictures when I was dealing with the virtual machine and how I wanted the stack to work and everything. And again, we'll get into that at some point in the future. But yeah, this is there's a lot of parts to it, which is why I think it's so difficult and why I want to take it, a step at a time. Okay, let's go back. Let's look at the overview, or what is the overview. Make myself a little smaller because I'm going to need the room. Again, we're going to start off with a script provided by the end user. Flex is going to take that script and identify tokens. The tokens are given to Bison, and then Bison is going to generate the abstract syntax tree. We take that abstract syntax tree and we create our own bytecode, which is the representation of the program in bytecode. And I say specified by Tang because I don't want this to be confused with any other bytecodes that are out there. This is our own. And then lastly, we will have a virtual machine that will execute the bytecode. And yeah, that's it. That's what we're doing. But then you might say, wait a second. We haven't even started. What do we do? How do we do this? Well, our immediate plan, and this video has gone on long enough just trying to set up how this works. We need to set up a development environment. We're going to use makefiles. We're going to use, set up a basic Flex and Bison skeleton. That just sounds morbid. Well, it's close to Halloween at the time of this recording. So maybe scaffolding is a better word. But we will set those up. We'll write a unit test or two. And then we will implement something in Tang. And it may be as simple as a 3. In fact, that's probably going to be the first one. Why? I don't have no idea. But a 3. And when it sees a 3, can it parse that into a syntax tree that represents the 3? Can it put that into a bytecode that when compiled will return a 3, just a 3, something simple. And once that's working, again, using all those parts, but once that's working, you just iterate through. And you document it along the way. Do not put off documentation until the end. Never put off your documentation. That's what we're going to do. Now, thank you. You've been very, very patient. Uh, for this next video, we're going to go into... I'm thinking I'm going to start off with a completely clean install. Well, I'm going to use Windows Subsystem for Linux, the WSL, WSL2 specifically, and develop in that. And I'll be using an Ubuntu 22.04. Well, actually, if you need to know, 22.04.01, I believe, is the image that's available at this time. And why? Because I want a compiler that supports C++ 20. And you can get one on Ubuntu 20.04.05. I tend to stick with the LTS, the long-term support releases. But anyway, I don't want to have to go through or walking you through installing a new compiler. It's all possible, but it's just you're going to start off with a brand new one. We'll install the parts that we need to install, and yeah, we'll get started at that time. So until then, yeah, well, this is like really scary for me because there's a lot of parts to it, but I probably won't post this until I at least get the first video or of actual setting up the environment as well. So, but I hope that you enjoy the journey as well. So thank you, and hey, have a great day.